I hate stages. You can see why. I went to Sweden many years ago, when I was 30 years ago, a long time ago. And I tend to walk to and fro, and I do my best to kind of, I think on the move, okay? I'm like that. I'm a good dancer, maybe. I don't know. We'll see. Anyway, so I was walking up and down, and there was a lady right at the front. And so I was 30. She was probably my age then, an older lady. I don't want to be sort of ageist. Is that better? I have to hold it really close? Okay, so be it. So I was walking up and down the stage, and there was a lady in the corner here. And every time I walked around here, she went, and I walked away, and I came back, and she's like this. And I said, "I'm sorry, everybody. Are you okay?" And she said, "I think you're going to fall off the stage." I said, "It's okay, I've been doing this quite a long time, whatever." And 1 minute later, I fell off the stage. So now I have two things to carry. How do I drink my water? I don't know. Also, I've got no monitor, and I don't rehearse. I have to say I don't rehearse, so I have to do this. So you're going to see a lot of the back of my head, I'm afraid. So I want to talk about an idea I've got, or I've had, for quite a long time. I've called it a new model for testing. Well, it was new in 2011, so it's not new. But then, if you know anything about history, quite often things get called new. So I went to a University of Oxford, and there is a new college there, and it's 450 years old. It's still called New College. So that was my theory, that I'll get away with this. It's a marketing ploy. It'll always be new. And I want to talk about that model briefly, but I want to say, what can I use it for? Okay? And I'm finding it over time more and more useful. And really there's a delay on this, I don't know why. I want to look at 5 testing questions, okay? Now, they may not be the ones that are most important to you, but 1 or 2 will be very important, okay? But I want to explore our industry and what we do a little bit, and use the model to kind of illustrate or highlight some of the issues we face, but also some of the opportunities, okay? And I think it's helpful. This is my thesis, okay? So I'll talk about 5 questions, and I'll talk about the model, and then I'll come back to the questions and say, well, look, this is how I'm thinking about these issues now. So I'm not, I've been a practitioner for 30 years, okay? But nowadays I could retire, but I choose not to, because I'm still active, but I'm not trying to make money. I'm not selling anything other than ideas. Okay, so I sell ideas for nothing, right? So there's no charge, right? So, okay, let's move on. So 5 key testing questions, okay? And they're not really testing questions. They are other issues. So the first one I want to talk about
You found the back.
There. It maybe needs a battery, I don't know. Is exploratory testing, I can stand here now, is exploratory testing different from scripted testing? Now, I know it's different. Can I ask, how many people do exploratory testing nowadays? Okay, and how many people do scripted testing? About as many, okay, and how many people are in the wrong presentation? Okay, so it's a black and white thing, isn't it? Okay, so that's an issue. Okay, what's the difference? Why is there a difference, and why does it matter? Okay? So, we're all very tribal, aren't we? So some people say exploratory testing is the only way to go, and some people say scripted testing is the only way to go. And there's no communication between these two groups. Next one. If I swear... What? There's no chance of the pointer working, is it? Oh yeah, there we go. What skills do testers need? Well, we already know that, don't we? I don't think so. Okay, I'll come back to that. Oh no. What did you do? Did you touch anything? It's okay. Well, okay. I'm going to get annoyed with this thing in a minute. So next one is, where can AI support the 12 tester thought processes? You don't know what they are yet because I haven't shown you the model. But where does AI fit? Will AI replace us? Is that question on your agenda nowadays? Is your boss saying, where can we use AI to get rid of you? Is that the way it works? Next one. Oh, for God's sake, I'm not going to use this anymore. I've had enough. I'm going to have to walk to and fro. Oh. Right. Can tools replace testers? Yes, of course they can. Go and ask the vendors out there. They won't tell you that, but they will tell your boss that, won't they? And your boss has the money. Here we go. Next one. Using the model as a guide. What might future tools look like? So I want to talk a little bit about the way perhaps we really should be using tools. We're on a 50-year journey. We're 2 years into it with AI. We're really at the very, very beginning. There's an awful lot more we need to learn about how to use AI, and there's an awful lot more AI that's going to come our way. What can we speculate about in terms of what will happen in the future? Okay, so I want to talk about the model. Okay, I want to try and address those questions, but using some ideas I've had for some time. So here's my kind of thesis, my theory. Everybody in this room tests in a different way. But I think there are some thought patterns, some thinking that everybody does. Now, this is quite an ambitious thing to say, and some people disagree. Oh, no, we're all different. Yes, I'm not saying you all think the same thoughts, but the patterns of thinking, the process of thinking, I think there is a pattern to that we all follow. Okay, that's kind of my thesis, right? So what the model is a model of the way we think. Now, if AI, for example, is about artificial intelligence, surely we need to know how we think before we start using an artificial thinker. Shouldn't we? Kind of makes sense to me. So that's kind of where I'm coming from. So I'm going to talk about models quite a lot. So I just want to spend a moment just to saying what I think a model is. Here's a chap, a man, who's thirsty. I will demonstrate, okay? I am thirsty. My water's over there. I'm going to walk over here, walk this way. And I can pick up the bottle and drink out of it. Put it back. Now, I did not fall over. I did not bump into the lectern. I found the bottle fairly quickly. I picked it up and didn't drop it. I got it to my mouth and drank. How the hell do I do that? There are about 100 muscles involved in just walking. And I don't know how many muscles there are in the body, but it's in the hundreds, okay? So how does our brain control all those muscles? If you look at the robots, you know, the Boston Dynamics guys who are building these robot dogs and robot android machines, they're incredible. They are incredible, aren't they, what they're doing now? But they require huge amounts of processing to do what they do. Now, we don't have that processing, and this is chemical. It's not electrical, or it's not silicon, it's not that. We can't process data as fast as these robots can, but we're still better than the robots at walking and picking things up and so on. So how do we do that? Somehow, our brain has got a mental model of the world, my body, which understands the angles of all my joints. That's a joint, okay? That's a joint. It understands the tension in my muscles, and it's constantly changing these things to stop me falling over. If I'm standing still still involves the brain keeping control of the little movements and so on. How does our brain do that? Well, it builds a mental model, okay? Again, that's just a little bit of background. How our brain understands the world is through modeling, all right? Now, in the talk, I'm going to give now, you could replace the word modeling with understanding, okay? So modeling isn't an academic thing. It's not a mathematical thing. It's Every human being knows how to model stuff. It's just instinctive. We just do it, okay? So our brains are modeling machines. We're really good at modeling, okay? That's a given. So where does that leave us? Well, I don't know if you remember the Matrix, the movie, when Morpheus, if you haven't seen it, I'm really sorry, but you're going to have to run with this. Morpheus is the guru, the teacher, and Neo is Keanu Reeves, and he's trying to teach, Morpheus is trying to teach Neo how to jump across tall buildings, to jump hundreds of meters. And he says, free your mind. Get rid of all the clutter that's in your brain so you can think clearly. And this is what I want you guys to do. We're not going to jump out the window and across to tall buildings, but I need you to think a little bit by taking all the crap out of your mind. Okay? And I use the word crap advisedly. You know, what is crap? Okay? Isn't it? Gets in our way. Because I want to understand how we think as testers when we are testing. So I'm not saying for all your life get rid of the crap, although that might be a good thing. So here we are. So I want to suggest this. Clear your mind. Free your mind. Forget logistics. What are logistics? Well, the way I'm going to talk about this is, I don't care whether you document your tests or not. Test scripts, don't care. Exploratory testing, don't care. It's all testing, right? Whether you use scripts or not doesn't matter. I don't care whether you use tools or use humans or you use some other piece of magic to do your testing, to run your tests. I don't care what process you're following, whether you're agile or continuous delivery or waterfall or who cares. That's not testing. It doesn't affect the way you think about testing. It's just the outside world that drives some of your behaviors. I don't care what business you're in, whether you're in e-commerce or healthcare or insurance. I don't care. It's not relevant. It doesn't affect the way you think about testing. And I certainly don't care about what technology you're using. Technology, like all these things, are logistics. They're not testing. They're really important, but they should not influence your thinking about testing. Okay? So I want you to put all that to one side, okay? And I'd say, okay, now what's left? And some people might say, there's nothing left. All I do is work on tools all day. Well, you're in the wrong job then. You're not testing. You're just mucking around with tools. Okay? But there is. I want to suggest it's a thought process that we use when we test. Okay? Are we all right? Are all right with this? It's a little thought experiment. So, next question, next statement is, all testing is based on models. We read documents, we talk to people, we look at the old system, we look at the new system when it's available. These are all sources of knowledge, and it's very complicated, and we build mental models to build our understanding of what a system should do. And when we've done that, we think, aha, I'm ready to test. Don't we do that? Wherever you get your information from, at some point you say, I think I know how to test this now. You make that conscious judgment, that decision. So, next statement. And I'm kind of going to give you in 3 levels. I'm going to give you the mission statement first, and then I'm going to give you an overview, and then I'll give you a bit of detail. Okay? It'll take about 10 minutes, hopefully. That's quarter of an hour gone, isn't it? Okay, right, jolly good. Okay, so this is what we do. We explore sources of knowledge. Those sources of knowledge could be requirements, could be business stories, user stories, could be the old system, it could be users that we interview, it could be stakeholders we interview, we talk with, whoever. The new system is a source of knowledge as well when it arrives. Okay? We explore sources of knowledge to build mental models, to build our understanding. And when we think we know enough, we can use that information to inform our testing. Okay? We can pick things to test. We can look at edge cases. We can look at flows, paths through the system. All this other good stuff. It's all based on our mental model. Right? Is anyone arguing with me yet? I don't want an argument. I'm not saying I want an argument, but I mean, have I upset anybody yet? I can see someone going, I want to talk about tools. No, there's no one doing that, don't worry. So that's it. That's from the mountaintop, right? We explore sources of knowledge, we build models to inform our testing. That's the mountaintop. So now let's break it into two sides. There's exploration and there's testing. On the left, we create test models from sources of knowledge. And at some point we decide, I think I know enough to test. And we go from exploring to testing. Now some people might call that checking. I don't care. That's just a name for the same stuff. Okay? But if you're a context-driven tester, we are in agreement. I call it testing, you might call it checking. That's a debate for the pub. I think you're wrong. I've got a better explanation than you have. I know that because I've been saying it for 15 years and no one's argued with me. How can I say that? Well, because it's true. Now, so when we do testing, we might discover, oh shit, the requirements are wrong, or there's a gap in requirements, or there's an ambiguity in requirements, or I thought it should work this way, but it does something different, and that might be right. The requirement might be incorrect, might be wrong. I'd better go and talk to the users, figure out what we do now. So you go round this loop. Now we want to be on the right. We want to know what we're doing. But quite often we have to go backwards a little bit. Does that sound familiar? We're always going backwards a little bit. Nothing changes, right? Nothing is new. So our sources are fallible. They can be wrong. People make mistakes. I've not mentioned AI yet. That's another debate. But people make mistakes. We're all human, literally human. Now, the thing in the middle, I would say, is this green blob called judgement. We make a decision that says, I think we know enough to test. Or we don't know enough to test because our tests are not telling us what we thought they would tell us. We've learned something about the system that is incorrect. But the users might have got it wrong. It might be the system, it might be the environment, it might be a million things that can go wrong in our testing. Okay, we know this. So, now, any developers in the room? Ex-developers? I am a developer. Yeah, I don't know why I do testing. I just find it easier to talk about than develop. Development's so boring. What are they all doing next door? It's boring, isn't it? Testing is much more interesting. Developers explore and test in a similar way. They've got the same sources of knowledge, they've got the same thought process, they've got the same problem, except they have to write some code. And when they write the code, then they test, and then they go through this process. That's my thesis. We're all the same. We all test in the same way in our thinking. So, okay, so that's the halfway down the mountain. Are we okay? You're with me? So now I'm going to look at, in a bit more detail, on the stuff on the left. I have sources of knowledge, requirements, specifications, stories, if I'm lucky. People, users, stakeholders, whoever. We've got the old system. If we're replacing it, the old system is a source of knowledge, of course. We're going to replace some of the functionality exactly. Some of it we're going to completely rewrite and add new stuff. The new system, when it arrives, is also a source of knowledge. Of course it is. It has to be. Okay? So what we do is we inquire. We ask questions. We read documents. We explore the system. We interview people. ... We do all this good stuff, gathering information. I call that inquiring. And when we inquire, we build that into our mental model. We build our understanding over time. Now, I've said models equals understanding. So if it helps, just think understanding. When I say model, you think understanding. My knowledge is improving. Now what can we do when we have a mental model? Is we can make predictions. Because what we can say is, well, if I enter A, B, and C into the system, then it should do D, E, and F, maybe. Because I've learned that from the requirements, or the users, or the old system. We can make predictions. And when we can make predictions, we can also say, you know what, I don't think this is right. So I can challenge my sources. So I can go to the users and say, I've read the requirements, and I think if I do A, B, and C, then the system should do D, E, and F. Now, what are the choices for the user, or the user manager, or the stakeholder? They can say, that's perfect, Paul, well done. Or they can say, it's a bit more complicated than that, isn't it? We should look at the requirements in a bit more detail. Maybe there's an extra thing we have an input, or there's an extra choice, or not all data, not all A's are valid, or not all F's are valid outcomes. There's more detail. Or it could be, and on occasion this happens, the user or the business manager or the stakeholder says, oh my God, we're going to have to rethink the whole design. Has that ever happened to anybody? Yeah. Just by asking a stupid question. What happens if? And that's what challenging is all about. You're testing your sources of knowledge. And we've all heard of testing through the life cycle, shift left, whatever. That's how I explain it nowadays. Okay? So we can improve requirements. We can improve sources of knowledge. Pretty much that's it on the left. Oh, sorry. And then we make a choice. I think I know enough to test. Okay? I'm ready. I'm ready to start thinking more carefully about testing, building tests. Now, if you imagine that's all to move to the left, and I've got my model, what happens then? Well, I can use my model to inform my testing. I can get tests out of these ideas, this understanding. And I can then apply those tests. I could say executing, running, trying, playing, I don't care. I use the word applying. I'm taking my knowledge of the system and my tests and apply it to the system under test to see what happens. And I get a result, which I need to interpret. I need to understand what just happened when I ran this test. When I interpret, I might log bugs or successes. Don't care. That's logistics. That's nothing to do with testing. Incident management has nothing to do with testing. It's about taking pieces of potential work, prioritizing them, evaluating them, triaging them, executing the required action, and then retesting. Okay, then we come back into the retesting field. So we have this kind of little detour called revise the system. That's not part of the model. It's a practicality, but we have choices on how we do this. So if we have a choice, I'm going to call that logistics. Okay, and the next thing is we would report progress in a bulk scale. We've run 100 tests, we report on 100 tests. Where are we now? Okay? Finally, we might also discover that our model is wrong. Oh, you know what? We've been running these tests, they all show a pattern that I think there's something more complicated going on in the software. Maybe we don't understand the requirements as well as we should. So we might have to refine the model. We have a word with the developers. What have you built based on this requirement? Oh, you had a conversation we didn't know about, didn't you? So we need to understand what you talked about and you have to catch up. That kind of game. And of course, we might have to go back. Our sources of knowledge are wrong. There's something we've missed. There's an ambiguity. There's an inconsistency or a conflict, or there's a gap in the requirement, and so on and so on. You get the idea. Right. So if I do that, if I put it all together, this is what you end up with. It looks like a bug. It's a complete accident, right? Well, it looks like a bug to me. I should say it wasn't just me doing this. I ran 2 or 3 workshops with some friends of mine, and I said, I've got this idea of creating a mental model, and it took us about 6 hours to come up with all the different arrows and activities, whatever, and I just glued it together. Okay, so it wasn't just me. I'm not that clever. But that's it. If you want to see a longer explanation, there's go to my YouTube channel, you can see one there. Just look for new model. So that's the whole thing, end to end. Sources of knowledge, which we explore, we create mental models, our understanding, we do testing. Oh, wait a minute. System under test, isn't that a source? It is. It's a slight anomaly in the way I've drawn it. Okay? But that will help us to answer a certain question. You get the idea? So I think that's how we think. It's not what we think. Okay? So, the new model is not a process. I'm not saying, okay, just write all your process document in terms of that. That's not what it's about. It's about how the patterns of thinking change in our mind. Our brains are so good, some of these things, we can do more than one of these at once. Our subconscious thinks about stuff, doesn't it, without us knowing. So quite often, there's multiple activities going on in our brain. We're that smart. What else can I say? So it doesn't tell you it doesn't tell you what you think. It just suggests what the patterns of thought are that we use again and again. Now, I think it helps us understand what we need from logistics. So logistics could be process, people, data, incident management processes, tools. You know, it helps us understand what we actually need. If they're going to help us think, now we know how we think, maybe it can help us. Okay, so that's kind of the thesis thing. It helps me to explain some difficult issues in testing. It helps me, and I think it might help you. So, okay, so that's the model. You got it. There will be a test later. Oh, sorry, there's meant to be another slide there. All right, so it's not new. So when I've presented that and stopped and said, thank you very much, clap, 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 any questions? Somebody would say, oh, that's not new, I know all that. And say, yes. So maybe it's a bit closer than you think to reality. The only complaint I've ever had is, well, that's not new. I know all that, that's what I do. Yeah, all I've done is write down what I think everybody does. And if it sounds familiar, you know, that's a good thing. It's not meant to be completely unique, a new way of thinking. No, this is how we think now, and perhaps always have. When did you start testing, can I ask? What's the earliest, when was the youngest age you remember testing? 18, 17? I don't know. I suggest to people that we start testing when we are 6 months old. Why? Suppose you give a baby, a 6-month-old baby, a Lego brick. What do they do? What do they do? Straight in the gob. They test it, they taste it, you know. That's how we learn. We are born testers. We are not born developers. Right, so let's go back to the questions. So, is exploratory testing different from scripted testing? The new model says, not really. Now, I'll explain that in a second. But I want to suggest all testing is exploratory. The exploration we do is when we are looking for knowledge to help us understand requirements or how to test. The exploration part is about gathering information. Obviously, it's not about results. When we test, you know, when we do a check, you know, that's a mechanical process. That's not exploratory, I would say. But even when you're doing even when you're doing scripted testing, you don't switch your brain off, do you? You're still looking for anomalies. You're still looking for patterns. And if something doesn't appear correct, you look a bit further into it. If you're a good tester, a bad tester would say, oh, no one will know that. Only I know that little problem. It's 10 to 5 on Friday. I'm going home. Yeah, maybe, but let's not go there. So even when you execute a scripted test, you are still thinking. You're navigating uncertainty. You are. You know, what else have I said? Interpreting information, you're still trying to understand how the system works constantly. And you're making decisions based on what you see and your mental model. Okay? So I don't think there's a big difference between the two. It's one of logistics. I'm writing stuff down before I run a test, and that I don't care. I don't care. The thought process you go to write a test down is the same as you put a test in your brain and saying, remember to do that, Paul, in about 5 minutes. Yeah, cool, I'll do that. I don't see the difference. Same thought process, I'm just not writing stuff down. That's not testing. Writing stuff down, is it? And now, if you take the model as I showed you a moment ago, the system appears on the right, the system is a source of knowledge on the left. I'm going to have to sort of drop the mic, but if you bend the model around and you join it up, you get that is exploratory testing. It's the same shit, right? I don't mean shit terrible. It's the same stuff. It's the same thought process. It's speeded up. We're not encumbered by documentation. We are encumbered by the system not working. We're encumbered by having to talk to stakeholders and users. We're encumbered by environments, data, all that other stuff. None of that changes. Most of that is logistics. So, okay, moving on. The real difference is logistics, okay? So understand what is logistics and what is thinking, and you'll make progress, I would suggest. Some of these things I don't want to talk about. Yeah, you know that. What skills do testers actually need? Well, if you look at each of the thought processes, you could imagine what would come, you know, what do I need, what capabilities do I need to do good inquiry, to do good modelling, to interpret results. You could think about that in a little detail. It's not that complicated. But kind of the ultimate skills are kind of modelling and abstraction. That's a skill we need. Judgement and decision making. Do I know enough to test or not? And communication and collaboration. Testers talk to everybody, don't we? We have to, because we're so desperate for knowledge. You know, no one tells us anything. We have to go out and find it, don't we, quite often? And we are the last to know. Okay, I don't want to be a victim. I don't mean, you know, we're all victims. I don't mean it that way. But we just get forgotten a little bit, don't we? Anyway, so we have to work hard at that. So our skills in social skills have to be much better than developers. And they are, usually. I'm not anti-developer. I'm a developer, right? So I'm not anti-developer. You can read, okay? I'm not going to go through these in any detail. But for every skill, for every activity, thinking activity, there's a skill or 2 skills or 5 skills that are associated. I'll share the slides. You can look at it later. But it's all pretty obvious stuff. It's not complicated, this. What else? I don't know why I've got this odd sub-bullet here, but anyway, I should say that some of this was written by AI. But I don't disagree with it. AI can be really useful. Don't be afraid of it. So, informing, test design and coverage thinking. Yeah, it's a testing skill. Applying, observation and attention to detail. That's a human skill. Interpreting, analysis and contextual judgment. We have to pay attention to our environment, the people we work with, the organisation, the culture, the data environment, the technical environment. All these things affect how we do our job. We have to be context aware. Of course we do. How can you not be a context-driven testing? Except I don't think we're context-driven. I think we pay great attention to context, but we are human-driven. I drive testing, not the context. But I pay attention to context. Reporting, storytelling, and stakeholder awareness. You need to know who your audience are before you tell your testing story. And so on and so on. Judgment is massive. Do I know enough to test? No. I need to go and talk to the users, to the stakeholders, to managers, to the architects, to the developers, whoever. Need to do that. We need to do that. Enough of that. Where can AI support the 12 thinking activities? AI is not useful everywhere. What a surprise, you know? I can't read that, actually. My eyes are going. I think the new model maps where potentially we need support and where AI can help. And AI will tell you what it can do. Just say, can you help me to do this process? And then describe it in detail. AI will tell you what it can do. It's kind of quite clever, really. Anyway, so this is not very clever kind of approach, but between myself and ChatGPT, I said, well, can you help in each of these 12 areas? And we ended up something like this. So, forget the 0, that doesn't have meaning. 1 is, I can't help. 2 is, help a bit, ... 5 is, I can do the job. Now, that is not the best way of doing this, and I'll show you a better way in a moment, but I didn't have time to put it in the slides. But there's a range of things it can do and cannot do. So very quickly, I'm just going to go through. We intend. Right, super. So I think there's a better way of scoring this AI capability. Okay? So something else I'm working on separate from the new model idea is this kind of scale of trustworthiness, autonomy. Do I trust AI to take the whole job? You know, the Terminator robots who are going to fight wars for me? That's probably the ultimate. Or do I use it just as a gopher? Go and find stuff. It's like Google, not much more than Google. And there's a range of things. I'm quite a big believer in, this is kind of easy stuff. That's what you do when you first get introduced to AI. And after a while, you start asking it for advice. Here's my problem, how do I solve it? And then you'll get pages and pages of ideas. Fantastic. Except it can be wrong. The real skill of using AI, I think, is in using AI as a coach. Okay? I have no time to talk about this. It's one for the pub later, or in the bar, or wherever the drinks are. Okay? And then beyond that, this is kind of human interaction, usually through a chat interface. You cannot do any of this without agents and software. Okay? So I think this is a better way of judging whether AI can help us. Okay, but I haven't used it. I just didn't have time to plug it in. So I'm stuck, for today, stuck with that. Okay. Watch this space. Follow me on LinkedIn and you'll hear more about all this stuff. Oh, sorry. The big opportunity is, guess what? Test execution. Of course it is, because it's a mechanical robotic activity. Except with a robot, you lose the human observer. It's not all win. Okay? It can do the mechanics, but it doesn't have any judgment. So even then, it can't do that 100%, I would argue. Informing, logging. So informing is about test design. Potentially, AI will get better to do test design from requirements. Logging, mechanical. Reporting, potentially mechanical. Although it has to know who the audience is. But you can tell it who the audience is. And if your stakeholders are collaborating within the context of AI, the AI will know who the audience is and it will report accordingly. The potential is there. Okay? I think that's a good thing. With the human in the loop, just to check everything. But beyond that, I think AI is struggling. Okay? AI can't do all the 12 processes. It just can't. AI lacks business context, political awareness, and the ability to judge what matters, what's important. It doesn't know that. Even if you tell it, it won't really understand. Okay? It's a more complex choice. So, can tools replace tester? Today, no. Tools can replace testers who just run tools and drive execution. Yeah, it can replace you guys, those guys. But AI and tools can augment it significantly. AI has value, okay? Don't just turn your back on it and say, it'll never happen, it's a load of garbage. That's not true. AI will become more and more useful over time. Need to go quick. What tools can do? Augmentation, not replacement. They should be designed to help you, not replace you. What might the future look like? Now, I've got some statements here. But I've got a much better video if you're interested. Look on my channel. Tools should support thinking, not just automate logistics. So tools are good at doing logistics. Okay? They're good at that, because these are mechanical processes very often. They're not good at thinking like we do. I don't want to talk about this really. You'll have to look at the slides. I'm running out of time quickly, so I need to move on. The key principle for future tools, design tools around cognitive processes. I didn't say that, AI said that. AI knows what it can do. It knows what it's good at. It knows what it's not good at. So trust it to be honest in that respect. So here's my summary. The model suggests how we think, not what we think. It shows you patterns of thinking that I believe are universal. Okay? It helps you to understand what you need from the logistics. You should design your processes and your tools usage based on what you think and how you think. I think that's a better way of getting better tools. It helps to explain stuff, like exploratory testing, the use of tools, independence. It helps explain all that kind of stuff. It's not new. Of course it isn't. Nothing is new. Okay? The Bible said that, Anyway, with that I'm done. And there's no time for questions.
There are 5 minutes for questions.
So we have one question in the chat, and it's, when you are challenging things and you are successful, and it actually goes to, we have to rethink the whole thing, and then everyone else in the room starts hating you, what to do about that?
Well, why do they hate you? Because they don't understand what your job is. Your job is to demonstrate the system works perfectly. It is. Your job is the same job as everybody else. But you cannot do that if there are known bugs. You've got to tell the truth. You've got to be honest. And projects have to be honest. And if someone says, you're holding us up, I said, okay, go live with this bug. See what happens next. You know what happens next. It's a shit show. Or it can be. I'm sorry for swearing. Well, I'm not sorry, really. It's just, it makes a point. And it gets a laugh. It's a cheap laugh, isn't it? Yes. But I think if people say that to you, they don't understand they don't understand their role in a project. Their role is to ship high-quality software and systems. And you said it's not high quality. Oh, and I don't write bugs. I don't write code. I don't put bugs in. I don't take bugs out. I'm just saying what I have seen with my own eyes. And also the users have seen it, and they're saying, this is awful. You've got to sort it. If you have to defend what you do it on the basis of, I work on behalf of the users. I work on behalf of the project manager. I work on behalf of the technical architect. I work on behalf of all you guys to keep you out of trouble. If you don't think that's helpful, I'll stop testing. Just give me a blank sheet of paper and it can stay blank. I won't write any tests. Is that okay? Oh, no. Of course not. They should grow up, all right?
I don't see any other questions, but you can ask them directly. We still have 3 minutes. So, any questions about it?
Okay. My watch says I should be finished.
You should be finished at 15.
Okay, well, 30 seconds. Go on. What's the first law of test management? If someone cuts your budget, or the timescales, or the developers deliver late, what do you do? Do you roll over and say, oh, I'll do my best? No. Which bit of the system shouldn't I test now? Well, what do you mean? You can't you just sort of do it? And ask the developers to say they're going to write code in a shorter time. They know it's going to be a shit show. Or they'll say, which bit can we cut? You should do the same. You should say, which bit of my professionalism do you doubt? Do you doubt my ability to estimate? Well, you always add a bit of fat. No, I don't. I don't add fat at all. I'll tell you how long it's going to take, and if you cut that, I'm going to have to do less. That's how it works. That's being honest. Okay? So when someone says, oh, you've got 5 minutes left on a talk, you think, fine, oh, we started 5 minutes late. I'd say, oh, do I get the extra 5 minutes at the end, or what? Or which bit of the talk shall I not do? Shall I not do the closing slides? No, you can't do it. You've got to be honest. Anyway, I'm just trying to fill up time now, so I don't have to answer questions.
And the time is up. So
I'm here all day. I'm here tonight, so please come and talk to me.
Thank you a lot, Paul.